This video summarizes the first 4 months or so of a one-year project called iMedic, an immersive medical environment for distributed, intuitive consultation. iMedic is funded by the U.S. Army TATRIC and is a means of immersing medical professionals together in 3D and 2D medical data for purposes of diagnosis, planning, and education. The Two-Handed Interface, or THI, is a fully immersive interface based on a pair of tracked button controllers called space grips. The space grips depicted here are wired, but a wireless version is also available. THI is both powerful and elegant. It's easy to learn and yet supports the most rich and ambitious of 3D tasks. We will at every opportunity take advantage of the strengths of the Two-Handed Interface during the course of the project. Let's take a look at how the interface applies to more representative data. This data was supplied by the University of Maryland Medical School. It's DICOM data that was segmented in a mirror. We massaged the data so that it could be loaded into iMedic. Here we're just looking at the clearances between vertebrae to demonstrate navigation with the Two-Handed Interface. Now we grab the skeleton and flip it over and shrink our viewpoint to enter the spinal column. This is the toolbox. You toggle the toolbox with a simple button press. It always floats over the left hand. The toolbox presents the user with iMedic's tool set on various panels consisting of standard 2D widgets and some natively 3D ones as well. Now let's take a look at the shader panel. The features on this panel let you control how the data renders. The purpose of this is to emphasize spatial relationships in the data. We select the object to be affected by shooting a ray through it and then simply selecting the shader we want. Perlin lets us change contrast and granularity. Like most of the other shaders, it's really a 3D field of texture. Notice how the object slides through that field. In Phase 1, we'll be evaluating iMedic against various tasks, such as measurement and recognition. Here we're measuring the distance between two vertebrae. For a more exact measurement, we use the Two-Handed Interface's fluid scale to place the endpoints more accurately. There's a multi-point option that lets you measure the distance along curved surfaces, keeping a running tally of the length. Two-handed operations will lend themselves well to area, volume, and counting operations as well. A key feature of iMedic is collaboration. Here's another user, potentially in another city, examining some feature in the data. This is one of many possible avatars. More will be developed later in the project. THI's fluid scale translates naturally into collaborative visualization. It's easy to see what the remote user is looking at, not just from a position and orientation standpoint, but from a size standpoint as well. Here we follow the remote user into the recesses of the data. The focus of the remainder of Phase 1 is on distributing data to several users as the data changes during the course of a session. We will then collaboratively validate the approach with test subjects. Phase 2 will in part bring collaborative 3D whiteboarding, drawing in space and on tissue for purposes of surgical planning and education.